For the examples in this section, I created a basic 6 shape. And here's the code that creates it. I'll go ahead and execute this so you can see the shape. So there's the binary representation, and there are the spatial results. In fact, I'll make it a little bit bigger. There we go. All right, so what this code does is it uses a circular string object. So that's one of the objects provided by both the geometry and geography object. And the definition for this kind of object takes a minimum of 3 parameters: a starting point, an anchor point, and an end point. So in this case, I started at 0, 4. So there's 0 on the x-axis. The actual x-axis is way down here, so 0, 4. So there's the starting point for this shape. And it goes around like this and continues up like that. So the required 3 points here define the arc of the string so that the shape that's defined by these 3 points is a portion of the circle that contains all 3 of those points. By adding additional points, you can add additional arcs to the string. And in fact, I first need to define a perfect circle, and that requires 5 points. And these are the 5 points that define that circle at the bottom of the 6. And then this remaining code defines an additional 2 points. Now, I need 3 points, so what it does is it uses these 3 points. So this is a point that it shares with the definition of the circle, and then it continues on from that point. This is the anchor point, and then that's the end point. So I start right there. I have one endpoint there, one endpoint there, and then I need a midpoint, and this is at 110 right there, in order to define that arc. So just keep in mind that you need 3 points, and the 3 points define the arc of the circle. And when you play around with the code like that and create different shapes, you can see how to define the sort of shape that you need. And in fact, I had to fiddle with this a little bit to get this anchor point here in just the right place in order to create the nice 6 shape. Okay, so there we have a basic shape. I'm going to use that for the next few examples. So one of the things that you can do is you can create a bounding box. This is a rectangle, which is a polygon, that completely encloses the shape. So it's a polygon, so it has straight lines. All right, so I'll go ahead and execute that. And now I have 2 shapes. I'll talk about the reason why I'm returning the 2 shapes in just a moment. But there's the final shape. So on the interior, I have that same 6 shape that I defined earlier, which is this circular string right there. And then I use the ST envelope method. Again, this is one of the OGC defined methods in order to create this bounding box. Now, a couple things about this select statement. I wanted to display both of the shapes within the Spatial Results tab. And so in order to do that, I have to return multiple rows of data. So if I go back over to the results, that's why I set up the select statement as a union all in order to return the data using a single column. Because I can only display 1 column at a time. Now, other products that display spatial data may be able to be a little bit more flexible, but this is the reality of working with the Spatial Results tab within Management Studio. Okay, so I union those 2 select statements together, and then this method returns another object, in fact a polygon, that has this shape that exactly encloses. So it's that this left line is at the leftmost point of the 6. This right side is the rightmost point of the 6. If this line had extended further over to say here, then that bounding line would be over here instead. And then this is the top, and then there's the bottom. And so it's very easy to use these kinds of methods within SQL Server in order to return these kinds of meta shapes, if you will. All right, then another option is to create a convex hull. This is a fairly complex shape to describe, so I'll first just go ahead and run the code. So there's the 2 objects, and then I have the 2 superimposed shapes once again. Okay. So what this is doing is this is creating a shape that includes the entirety of the shape that I'm basing it on, and I'm basing it on this 6, so that it follows any concave lines. So I have concave lines like this, but as soon as the shape is convex, essentially, then it just continues across a straight line to the outermost point there. Kind of difficult to create writing transact SQL code. In fact, it'd be a little bit complex to create using .NET code in a client application, but you have a method here, stConvexHull, that defines that kind of shape. So I just call that method, it returns this kind of an object, and I'm done. Okay, another handy thing is to use the stBuffer method to create a polygon that bounds the line to include all points within a certain number of units of the line. And in fact, this is the technique that I used when I made the point on an earlier example more visible. Okay, so here it's using that same 6. I'll go ahead and run it first. And there's the result. So I'm just calling stBuffer. I'm giving it a measurement of 2 units. So this outer shape is 2 units away from the line. You can see that more clearly here. So there's the root. It goes out 2 units. Down here goes out 2 units. This is 0 and minus 2 there. And so this bounds that shape. And this unit, again, this is the number of units. So I'm just using that shape, calling the method on an existing shape, doing union all. And again, this is just something that I'm doing in order to make it convenient to view the shapes within the Spatial Results tab. Okay, so let's get away from the 6 now. Here's some additional code. I'll go ahead and execute that so you can see what's going on there. And there's the shape, just a simple rectangle. But what it does is this also calculates the area and then length of the perimeter. So you can do that manual if you want, but you can also use stArea and stLength. And in the case of a polygon, that's going to be that perimeter area, the length of that line plus that line plus that line plus that line. Okay? And there are the results. So the area is 78,200 and the length is 1,140. This is a really cool feature of SQL Server and the support for spatial data. You don't have to worry about remembering all those complex equations for calculating the areas. Rectangle's pretty easy, but when you have more complex shapes, that can be quite a nightmare. And then you can also have SQL Server perform even more complex calculations. One example is to find the centroid of a triangle. Go ahead and execute that code. There are the results. And there's a point, and I'm using the buffer once again, stBuffer, in order to make it a little bit bigger so you can see the point. And that identifies the centroid of that triangle. And once again, it's very simple. And this points out that you can chain those methods. So this is using that T1. This is a polygon, which is a triangle. It's calculating the centroid, which returns a point object. And then on that object, it's going to buffer that 5 units in size. And that's the result. And then one other thing is that if you want to get the well-known text for that centroid, instead of plotting it, you can use code like this. So T1 is once again that same polygon. And then rather than plotting it or returning the well-known binary value of that, I'm using the toString method once again, and that returns that value.